Welcome to Hayagriva Classes YouTube channel. Here we bring you the second video in Differential Calculus, Lesson 2 on Chain Rule. In the last video, we saw some basic concepts of differentiation and what is the meaning of differentiation. In this video, we will cover one important rule that we follow, the chain rule in calculus. Now, what is this chain rule? Have a look at this example, children. Suppose we have y is equal to x cube. Okay? If we are going to differentiate it, we will write dy by dx is equal to, I have used the formula for x power n. So, whenever we differentiate x power n, we will say n into x power n minus 1. Now, instead of n, we have 3. So, when we differentiate x cube, we get 3 into x power 3 minus 1, which is 3x power 2. What if we had been given, instead of x cube, 2x the whole cube? Of course, you would have just expanded it. 2x the whole cube is 8x cube. And then once again, you would have differentiated using n into x power n minus 1. As keep 8 as it is. X cube, when you differentiate, you get 3x square. So you get 24x square. Okay, this is fine when we are able to simplify functions. But the functions become very complex. We won't be able to simplify it and then apply normal differentiation. Just like that, directly from the formula. So I'll give you with a simple example how we can apply the chain rule, and later we will apply the chain rule to more complex situations. So look at this. Y is equal to 2x cube. So what we do first is, think of this like some x power n. So 3 into, instead of x you have 2x now. So 2x power 3 minus 1. But we don't stop with this. Instead of x, now we have 2x. So we go on one step further and put into differentiation of 2x. The differentiation of 2x is 2. So the function becomes now, after differentiation, 3 into 2x the whole square into 2. Okay, 2x the whole square is 4x square. So 3 into 4 into 2. So we have 24x square. The answer is the same. Okay. And for this problem, actually, it doesn't make a difference whether we use the chain rule or not. But in certain situations, we cannot avoid the chain rule. For example, take the next sum. Y is equal to sine 5x. So how will you differentiate this? Just differentiate as if you would differentiate sine x. Okay. So when you differentiate sine 5x, you will get cos 5x. But instead of 5x, what do you have there? You have some other thing. So differentiate that. So 5x, when you differentiate, you will get 5. So on the whole, dy by dx becomes cos 5x into 5, or 5 cos 5x. Next, suppose we had y is equal to cos 5x. So how would we use the chain rule here? Differentiate cos 5x as minus sine 5x. And then we go to differentiate 5x, which is 5. Take the next example. Y is equal to tan 7x. D by dx of tan x is secant square x. So tan 7x, when we differentiate, we'll get secant square 7x into, we should differentiate 7x. So if we differentiate 7x, we get 7. Let us try to apply the chain rule to solve some more problems. Take the first one. Y is equal to 10x the whole square. So first use n into x power n minus 1. So 2 into 10x power 2 minus 1. And then we differentiate 10x, which is 10. So our answer becomes 2 into 10x into 10. So that is 200x. In the second question, we've taken y as cos of 2x plus y. So when you differentiate cos, you get minus sine of whatever the angle is there in the question, you write it. So minus sine of 2x plus 5, and then go on to differentiate 2x plus 5. So if you differentiate 2x plus 5, you get 2, because you know that if you differentiate a constant, it becomes 0. So your final answer is minus 2 into sine of 2x plus 5. Next, y is equal to tan 5x. So derivative of tan x is secant square x. So differentiating tan 5x, we get secant square 5x into 5 when we differentiate 5x. So we get 5 into secant square 5x. Now we go on to slightly the next level sort of sums. Y is equal to tan of root x. So if you differentiate tan, you will get secant square. So secant square root x. But instead of x, what do we have? Root x. So we have to differentiate root x now. Okay. So if you differentiate root x, how will we differentiate root x? It is x power half. So use the formula half into x power half minus 1, which becomes half into x power minus half, which is 1 by 2 into root x in the denominator. Next, differentiating cot of root x. So the formula for derivative of cot x is minus cosecant square x. So we get minus cosecant square root x into differentiate root x as in problem 4. I will repeat it for the benefit of those who did not understand the method in the fourth part. Square root of x is x power half. So half into x power half minus 1, which is 1 by 2 into x power minus half. X power minus half can be written as 1 divided by x power half. X power half is nothing but square root of x. Next, differentiation of root of sin x. So you can think of root of sin x as sin x power half. So half into sin x power half minus 1. Okay, we have only x here. Where does the chain rule come? The chain rule comes because instead of root x, we have now sin x. So instead of x, the whole thing sin x. So n into x power n minus 1, and then we differentiate sin x. Derivative of sin x is cos x. So you get cos x divided by 2 into root sin x. What we have here are some more examples to illustrate the application of the chain rule. Y is equal to log sin x. So what do we have instead of log x? We have sin x. Okay. So first we differentiate as if it was just log x. So log of anything is 1 by that when you differentiate into. Then we proceed to differentiate sin x. So 1 by sin x into derivative of sin x is cos x. Okay. But cos x by sin x is cot x. So we have simplified it and written it like that. Take example 8. Y is equal to 8x square plus 5x plus 3 the whole power 4. So this looks like x power n. So first we'll use the formula for x power n. 4 into 8x square plus 5x plus 3 the whole power 4 minus 1, and next we should differentiate 8x square plus 5x plus 3. So again, now when we go to differentiate 8x square plus 5x plus 3, okay, 8 you keep as it is. If you differentiate x square, you will get 2x plus 5. Okay. So you have 4 into 8x square plus 5x plus 3 the whole cube into 16x plus 5. Next, we have to be a little careful when we differentiate functions which are trigonometric functions, and the argument or the angle is a little complicated. Take the example 9. Y is equal to sine cube of, now instead of theta you have 2 root x. Sine cube itself we cannot differentiate as it is, so you have to take it as sine 2 root x the whole cube, and first we will apply n into x power n minus 1. So 3 into sine 2x sine 2 root x the whole power 3 minus 1. Now instead of x we had sine 2 root x, so now we go on to differentiate sine 2 root x. The derivative of sine 2 root x is cos 2 root x into, then we have to differentiate 2 root x. Okay, derivative of 2 root x, 2 into root x can be taken as x power half, isn't it? So half into x power half minus 1, or half into x power minus half, so that root x can be taken to the denominator. Okay, I'll repeat this. First we do the differentiation by using x power n formula, n into x power n minus 1. But instead of x you have sine 2 root x. So next we go to differentiate sine 2 root x as cos 2 root x. But instead of x now you have 2 root x. So go on to differentiate 2 root x. So can you understand now why we call this the chain rule? Like a chain, it goes inside and inside till you come actually to differentiate x. Actually, in some textbooks, they will use a substitution, put t is equal to 2 root x and they will do it. That is, you will be able to understand it a little more easily, but this works out in the long run. And another thing is, my aim in this video is to give you a preliminary idea of using the chain rule. Okay, I don't intend to go into very deep into the topic because I am mainly doing this video for those who will be applying it in science, in physics especially. Okay, to do an entire course on differential calculus, we'll have to go a little more deeper into the topic. And I feel that what we have done is more than sufficient for you to cross the mathematics required in your physics topics. Next, let us apply the chain rule to one more problem which is slightly complicated. Y is equal to cot square of sin 2x. So I'll write this first as cot of sin 2x the whole square. So first x power n. So n into x power n minus 1. Now what do we have instead of x? Cot of sin 2x. So cot theta, differentiation of cot x is minus cosecant square x. So minus cosecant square, instead of x you have sin 2x. So now go on to differentiate, multiply it into d by dx of sin 2x. Differentiation of sin 2x is cos 2x, but instead of x we have 2x. So now you have to differentiate 2x also. So first we are using x power n, then cot x formula, then we are going to differentiate sine, and then we are going to differentiate 2x. Like a chain, it goes right inside. I hope you like this video and you are able to grasp the basic concepts of differentiation from this using the chain rule. Those students who are going to use this only for science purposes, you don't have to worry very much. They are not going to give you very, very difficult functions. But whenever you learn something, it is always better to try to grasp the concept completely. So the last two examples which I have given in the application of chain rule may seem a little complicated to beginners, but I am sure that if you put in some effort and try to understand the concept, you will definitely be able to use it in other problems. And for those who have taken maths as your subject, this will definitely help you when you come to the topic of differentiation and in the 12th standard when you apply differentiation concepts also. If you like this video, kindly subscribe so that you will be notified about the videos that are yet to come, okay, on calculus. Share it with your friends so that they also will be benefited and they can also understand calculus in a better way.